So welcome to this one more lecture on the scattering theory. And in this particular lecture, we will derive the relations between the scattering angle and uh, differential cross section in these two different frames, the lab frame and center of mass frame. So we will start by discussing what the lab frame and center of mass frame looks like. So for that, let me take an example that there are these two objects, right? So there are these two objects, and we are taking the example of one-dimensional scattering. So you all have studied these kind of things in your school physics. So let us suppose that there are these two objects or particles, and in the lab frame, this particular object, which is of mass m2, is at rest, right? So in the lab frame, let us suppose its velocity of particle 2 in the lab frame is 0, and the velocity of this particle, which is particle 1 in the lab frame, is some quantity which is not 0. So it is moving in the lab frame with some velocity, and it is not moving, so it is at rest, right? So this is the situation before collision. Okay, so what will happen after collision in the lab frame, right? The general thing. So what will happen is that uh, this is just the axis on which we are observing these two particles. So after collision, this particular particle will move in some direction. Let us suppose in this direction. Okay, and this particular particle, which is m2, this is m1, will move in some other direction. So we are taking that it is moving in direction theta 1 and it is moving in direction theta 2, and let us suppose that the velocity of this particle after collision is v1, because it is particle 1 in left frame. So and just put a dash to show that the velocity is after the collision, and let us suppose the velocity of this particle 2 in left frame is v dash to l. Okay, so this is the situation after collision. And we all know that if the scattering is elastic scattering, then the momentum before the collision of the system will remain same as the momentum of the system after the collision. So these and one more thing, if the collision is elastic collision, then the kinetic energy of the two different particles will also remain same. So this is just the basic situation when we are observing the collision in the lab frame. So right, so it is the lab frame. But it is not the situation when you observe the same thing happening in the center of mass frame. So what does that mean? Now you have to sit at the center of mass and you have to observe the whole situation happening. So let me explain you what you will observe from the center of mass. So what is the real situation? So in reality, this ball is at rest, right? Or let us suppose this particle is at rest, and this particle is moving towards this particular particle. So when you will be at the center of mass, what you will see is that this ball is coming towards you, right? And also this ball is coming towards you. Let me show you why you'll think like that. So initially, let us suppose the m1 ball is there, or the particle, and m2 is there. It has certain velocity in the lab frame, and it is the center of mass. So after some time, what will happen? This ball will be there in the lab frame, but this ball will move in this particular direction, and because of the motion of this particular ball, the center of mass will not be there. It will be somewhere in between, or it will shift according to the mass of these two balls. Okay, but it will not be on the same place. So center of mass is there. When you are at the center of mass, what you will observe, initially the distance of the m1 from the center of mass is this much, but now because of the motion, the center of mass, the distance between center of mass and the ball m1 will decrease. Hence you will see the ball is coming towards you, right? Not only that, the distance between m2 and center of mass will also decrease, right? That means you will also observe this particular ball moving towards you, right? It is something like it is also coming towards you, because when you are at center of mass, you will assume yourself to be at rest, and you will observe the motion of different things. So if this ball is coming towards you, right, in fact you are going towards that ball, but if you are at the center of mass frame, what you will observe, you will consider yourself at rest, and you will feel that this ball is coming towards you with some velocity, right? So in center of mass, or in the left frame, the velocity of this particular ball is 0, right, or the particle is zero. But when you will observe the whole situation happening from the center of mass, you will assign some velocity to this particular ball as well, right? So from the center of mass, let us suppose the velocity you assign to this particular ball will be v1c in the center of mass. Right? This situation is before collision, and you will assign some velocity which is non-zero to this particular particle 2 in the center of mass situation. Sorry, center of mass frame. So this is before collision, and I hope that you got the idea that why the observer from the center of mass will assign some velocity to this particular ball. Now, what will happen after the collision? So, after the collision, in the left frame, this particular ball or particle m1 will move in this particular direction. So, let us suppose this particular direction is theta in center of mass frame. And in reality, what is happening is that this particular ball is moving in this direction. So this is what is happening in the center of mass frame. So let us suppose this is just at time t is equal to 0 seconds, and you observe again at some time t is equal to 1 or 2 seconds. So the ball will be there, and this particular ball, let us suppose it has some small velocity, so it will be there. So it is m2, m1 moving with some velocity. So the center of mass of this particular system will be on this particular line joining these two particles. So it will be somewhere there. And what is the observer? What the observer at the center of mass will observe? It will observe that this particle is moving away from the center of mass, and as well as this particle is moving away from the center of mass. So after the collision, the observer from the center of mass will assign some velocity in this particular direction to this particular ball, and some velocity to this particular ball moving in the opposite direction to the to the velocity of this particular ball. So this is what the situation from the center of mass frame perspective, right? So you must have to think about it. So let me draw it properly. So from the center of mass frame, these are the velocity. So let me suppose this is mass m2. So it is velocity of particle 1 from center of mass after the collision, and it is velocity of particle 2 in the center of mass after the collision. So this is the situation, and let us suppose that this scattering angle in the center of mass frame is theta, and therefore this will be pi minus theta. It is after the collision. And the whole situation you are observing from the center of mass frame. So these are the situations that you must have to visualize first, right? So this is what you will observe in the lab frame, and that is what you will observe in the center of mass frame. And you must have to understand why in the center of mass frame even the rest particle is moving, right? Why the observer in the center of mass frame has to assign some velocity to the particle which is at rest in the left frame, and why the velocity of these two particles are assigned in this particular way in the left frame. Just think about it, you will understand that it is just easy arguments. Now what we will do, these are the scattering angles, right? So this is the scattering angle in the center of mass frame, and this is the scattering angle of the same particle in the left frame. So if you are observing from the left frame, this is the angle which you will observe in your experiments. But if you will calculate theoretically in the center of mass frame, which I have told you that calculations in the center of mass frame is much more easier. So what you will calculate is this particular quantity, the theta, right? So in the center of mass frame, this is the quantity that theoretically we will calculate, and this is the quantity experimentally we will calculate in the experiments. Now what we have to do, we just have to have the relations in between in these two quantities, theta 1 and theta, which is the scattering angle. This is the scattering angle of particle 1 in left frame, and this is the scattering angle of particle 1 in center of mass frame. So we have to derive the relationship between these two quantities. So this is what we will do now. So let me just draw these two diagrams here because we need to use them in the derivation. So this is what the situation is.